Hello everyone. In this question, it is given that if integration of cos x upon the product of sin cube x and 1 plus sin to the power x, sin to the power 6x whole raised to the power 2/3 dx is equal to fx times 1 plus sin to the power 6x whole raised to the power 1 by lambda plus c, then we are to find the value of lambda times f of pi upon 3. Okay, so we are given an integral and we have to evaluate this integral, and then we have to compute the values of this function fx and this constant lambda. Okay, then we can evaluate this expression. Okay, so if we start, we are given cos x in the numerator, and in the denominator this is a product of sin cube x times 1 plus sin to the power 6x whole raised to the power 2/3 dx, right? So the first easy substitution is like if you take sin x equal to u, then you get the du in the numerator, right? So if we start with this, let u equal to sin x, then du becomes the numerator, that is cos x times dx, right? So if we apply that, we have u cube times 1 plus u to the power 6 whole raised to the power 2/3 in the denominator. In the numerator this is just du. Okay, so in this term in the bracket in the denominator, if I try to take u to the power 6 common, okay, I am taking u to the power 6 common here, then the first term it will become 1 upon u to the power 6, right? Because if you multiply these two, u to the power 6 and this term, you get this 1 back, right? And in the second term it is just 1, because when you multiply this u to the power 6 and 1, you get this original term back, right? So I'm doing this, and this is whole raised to the power 2/3, okay, du. Now if you look carefully, this is u to the power 6, and if I take this term out of this bracket, then this becomes u to the power 6 whole to the power 2/3, right? So this becomes u to the power, if you multiply, this becomes 12 upon 3, so this is just u raised to the power 4. Okay, so if it comes out of bracket, this becomes du upon u cube, and this term out of bracket becomes u to the power 4, and the term that is left out inside the bracket is 1 upon u to the power 6 plus 1 whole raised to the power 2/3. Okay, so on further simplification, this changes to du upon u to the power 7 times 1 upon u to the power 6 plus 1 whole raised to the power 2/3. Okay, so I think we need another substitution here. So if you look carefully, if I try to do this this thing inside the bracket, another substitution, say t. If I start with, say, t equal to 1 upon u to the power 6 plus 1. Okay, if I do this, once doing the derivative of this 1 upon u to the power 6, I'll get minus 6 upon u to the power 7, right? So this thing, this du upon u to the power 7, this part is actually coming out, but this becomes t to the power 2/3, right? T to the power 2/3. So instead of doing this t to the power 2/3, what if I do this 3t cube? Because if I do 3t cube, then this fractional part will vanish, right? If I do the derivative, what I'm saying is, if I do the derivative now, then this will become 3t square dt will become minus 6 upon u to the power 7 du, right? So we have du upon u to the power 7, right? So du upon u to the power 7, this implies that I have to take this minus 6 to this left hand side denominator. Okay, t square dt, and this will become just du upon u to the power 7. So this changes to minus t square upon 2 dt is equal to du upon u to the power 7, right? And this changes to, this is minus t square by 2 in the numerator dt, and this is entire thing is t cube, right? So this is t cube whole to the power 2/3. So this is t cube whole to the power 2/3. So again, this just now changes to t square, right? So this is in the rough side. So this is just t square. So you see this t square and this t square actually cancel each other. Okay, so this just changes to now minus half dt. So you see if you do just t, the cancellations will be much less. Okay, if you do t cube here, so you see this term t square and this t square cancel each other. Okay, so this becomes very easy to solve now. This just become minus half t plus c. Now we need to do the two back substitutions here, right? For the first back substitution, t was this. Uh, if t cube was this, then t will be whole this from this here. T will be just this entire thing in the bracket whole raised to the power 1/3, right? Right, I'm not writing it here, I have to write in the actual sum here. Okay, so you get this idea, right? So this is t, so half t, this just becomes 1 plus 1 upon, this was u to the power 6, right? Now what was u was again sin x, right? So I can do this substitution also. So this just becomes 1 upon sin to the power 6x, sin to the power 6x whole raised to the power 1/3, right? 1/3 plus c. Okay, so again the format that was given was fx times 1 plus sin to the power 6x. So I have to take the LCM common here. Okay, so if I take the LCM common here, this will change to sin to the power 6x plus 1 whole raised to the power 1/3 times, this will be sin to the power 6x whole raised to the power 1/3 plus c. Okay, so this now becomes minus half times, this is sin to the power 6/3, so this is just sin square x. Okay, this just becomes sin square x, and this one is just sin to the power 6x plus 1 whole raised to the power 1/3. So I think this is now matching with this format, right? Fx times 1 plus sin to the power 6x, right? Fx, the fx will be minus 1 by 2 sin square x, fx 1 plus sin to the power 6x. So this is now 1 plus sin to the power 6x whole to the power 1 by lambda, right? So this is the format. Okay, so we have completed it. So fx now becomes just minus 1 by 2 sin square x, and lambda is nothing but 1 upon lambda, so this is 3 here, right? So we have found the two unknowns here. Now you just need to put these values in this expression. Okay, lambda f of pi by 3. So we have lambda f of pi by 3 will be 3 times this minus 1 by 2 sin square pi by 3. Okay, so if I isolate these constants here, this becomes minus 3 by 2 times sin square pi by 3 is root 3 by 2 whole square, right? So this is just root 3 by 2 whole square. So this is 3 by 4. So this will become 4 by 3. So this changes to minus 12. This 3 and this 3 cancel each other. So we are left with just minus 2. Okay. So I believe this is the required answer. Okay. This is the required answer, I believe, after all this computation. Okay. So this was actually lengthy. It was slightly tricky as well as lengthy question. You needed this slight manipulation while doing the back substitution. Okay, so I would say this was slightly hard question, slightly on the difficult side. But you have to practice such questions, and once you do these questions frequently, you will get used to it. Okay, so I believe this is the answer here, and if there is any mistake, you can highlight in the comments. Okay, but I believe this is correct. So this is it. If there are any doubts, you can highlight in the comments. Okay, I will reply to you. Otherwise, this is finished. Thank you for watching.